Hello YouTube. This is a C# tutorial on socket programming, but not just sockets, asynchronous sockets. This is going to be a multi-part tutorial in which I will make a really cheap and kind of crummy version, but still working version of a chat server messenger type of thing. So the first thing we need to start off with is building a socket system, and this always seems to trip people up, well, new developers anyway. And it took me a long time to get the hang of asynchronous sockets. So for this tutorial we're going to be using, like I said, asynchronous sockets, and we're going to be using the socket class. The reason that we will not use TCP server or TCP client is because, I mean, like, you can use those and like they'll work, but sockets, and especially asynchronous sockets, are a lot better because they have all the methods you would need to accept, disconnect, receive data, send data. It's just really easy with the socket class. And we are using asynchronous sockets instead of non-asynchronous sockets because the difference between the two is one blocks the main thread and one does not. A non-asynchronous socket, you can basically, what'll happen is if you're using one single thread and you tell it to accept a client, then it waits until it has a client to accept, and there's nothing you can do. Like, you can't really do anything on that same thread until it finishes accepting the client. If you ask it to receive data, it will stop the program until it receives data, or it'll stop the thread that it's on. So you can make a threaded non-asynchronous socket system, but you might as well use asynchronous sockets because they're a lot easier and neater and stuff, and it's just all good. An asynchronous socket will not block the thread. So if you tell it to watch out for any clients that are trying to connect, it'll do that without blocking your thread. So, it'll just do that in its own little thing, its own little space, its own little world. So that's why asynchronous sockets are the best to use. So the first thing we need to do is we need to start building our socket system. And that is a networking type of thing to do. So I created a new folder, called it networking, and here's where I'll put anything involving networking, like our socket system. So I'm going to call this a server socket, and the only namespaces we'll be using are system, system.net, and system.net.sockets. So right off the bat, I told you we were going to be working with the socket class, so we need a socket to work with. Since this is not a static class, we also need a constructor to work with. So when you create this new server socket, you want to initialize a new socket. And it asks you for 3 parameters. Asks for an address family, a socket type, and a protocol type. Now what the address family is kind of like how it finds its way around the network. There's multiple different types of networks, but globally speaking, you're going to be working with internetwork and internetwork v6, or I think it might be just 6. It's either 6 or it's v6. And for years we've been using IP version 6. That's, we have a maximum of 3 times 4, that's 12. A maximum of, I think it's, I don't know, it's a really big number, of decimal points or IP addresses and whatnot. So for the most part, we all use internetwork or IP version 4. That's the most important part you need to know. we will in the future be moving towards IP version 6, but for now we use internetwork, which is IP version 4. The next thing it asks for is a socket type, and this is what type of packets you're going to be sending. I'm not going to explain them all, but I will say for the basics, if you're using a TCP protocol, you're going to be wanting to use the stream socket type. And what this means is that basically you have to connect to a computer and get the "yeah, I'm connected" back before you can send any packets. It's making sure that there is no disconnecting going on. If it disconnects, you can't send any packet. It requires a two-way connection before there's any packet sending. And this is very good because you don't want to lose packets. Sorry, I forgot I was going to explain the difference. Other than stream, the only thing you'd probably use is dgram. Dgram is using the UDP protocol. And the difference, I already told you TCP. UDP is a non-connection or a connection-less type of packet sending. You just punch in an IP and a port and it sends the packet in hopes it gets there and does something with it. Or it knows what to do with it. This is really good for streaming. I'm not sure, but World of Warcraft might use UDP packets. I mean, you know, you can fiddle your own thing in there, which requires a connection before you send a UDP packet. But basically, UDP packets are meant for speed. They're meant for streaming video, streaming audio, because you know, if you have a good connection, if your internet's good, you're going to be getting a lot of packets, you know, right after another. Your movie quality is going to be good, and it's going to load the movie really fast, and that's what dgram is for. But for this, we're going to be using stream. And the protocol type is what type of packet you're going to be sending. In this case, it's a TCP packet. So once you've initialized your socket, there are some things you can start doing, like using the built-in methods. But there are also some things that you have to do first. And the first thing you need to do is you need to bind your socket. And in order to do that, you just call socket.bind. And it takes an endpoint. What an endpoint is an IP address and a port, and that is 1 point on a line. Your computer is 1 point on the line, and an endpoint is the other point on the line. And this line that I'm talking about is what is used to send data and get data on. So we need to make a new IP endpoint, and we need to give it an IP address. And for this, we're going to use ipaddress.any. And what this says is, I don't care what IP address this computer has, but whatever it is, use it. And we need a port, which is taken as a parameter. So that's what binding is. It basically says, okay, socket, I want you to work on this IP address on this port. Right now, this is basically the same as localhost, which means this local IP address. So that's what we'll do. After binding it, you have to make your socket start listening. And that takes one integer parameter, and it's called a backlog. So when you call socket.listen and it asks for a backlog, as you can see, it says the maximum length of the pending connections queue. In other words, it means how many backed up connections do you want until it ignores other connections trying to connect. I use about 500 generally. I mean, that's a pretty good number. Most computers can handle that. So, you know. After you've put your socket into a listening state, you can begin accepting clients. Let me check the time. I'll probably make this a 20-minute video for this first tutorial, but yeah, anyway. So when you start listening, you can just do something like private void accept. Okay. This is how you're going to start your sockets to accept, receive, and send data. So once you call this method, you want your socket to begin accepting any clients that try to connect. And it asks for two parameters. It asks for an async callback and an object. And what the callback is it basically says, okay, once we begin looking out for any connections and we get one and they connect, what do you want us to do? So I'm going to make a new method, and I think I'll name this accepted callback, and it takes an async result. So remember, the first parameter it asks for is what code to run once it accepts a connection. Whoops. The next thing it asks for is a state parameter in the form of an object. And what this is you can give it an object and it will pass it on to the callback. That's basically what it is. And I'll explain it once we start receiving data. But for now, you don't need to pass on anything, so I put null. So once it's accepted something, it's accepted a new client has connected to this server, this is what this method is for. So now we need to end accept, and we need to give it the result. This basically says, okay, I'm going to stop accepting any clients and accept this one right here. But the problem is that if we want to start accepting, we need to let it keep using the socket. So we need to create a new socket. And this is the client socket. Basically what this says is okay, this connection, because that's what a socket is, it's a connection between two computers. This connection is the connection between me and the newly accepted client. That's what it says. Now we can make the socket start listening for more connections. So once we've accepted the client and we grab the connection, this is a connection, we say, okay, now we want to get any data that they're trying to send to us, or we want to get ready to receive any data. So we begin receive, and it asks for some parameters. Now the first thing it asks for is a buffer. So give it a byte array, name it buffer. It's a new byte array. You can name it whatever size you want, or number it whatever size you want, but I'm going to use 1024 because whenever I do networking, I always accept my packets in chunks of a megabyte, or a kilobyte, sorry. Yeah, 1 KB at a time. You can go higher, a lot higher actually, but this is just my personal preference. I'm never really sending any data higher than that. So now that we have, and basically what the buffer is it's what you're going to be storing the data that you receive into. Sorry, this actually needs to go up here. What the buffer is when you begin receiving, it says, okay, what am I going to put the data into? And you're going to put it in the buffer. Now it asks, where in the buffer should we start putting the data? And you want to put it at the very beginning of the packet. I mean, that's just like kind of what you should do, what's normally done. There's really no reason to put it anywhere else, I guess. So I put all my data at the very beginning of my packet. I don't want any empty spaces at the beginning, so I put it at the start. Now it asks for how much data should we accept. And you want to accept however much your buffer can hold. And now it asks for any socket flags. And I generally put socket flags.none, although you could put something else. I'm not really going to go into it. That's what I put. And now it's asking for another callback. This says, once we've received data, where do you want us to put it? Or what method do you want us to call? Where do you want to send them? So we need to create yet another callback. And this is the received callback. And now it asks for an object. And what you want to do here is you want to give it the client socket. And the reason for that is because what it'll do is it'll take the connection and it will pass it to this. Because once you call client, sorry. Okay, I'll just that's what happens, okay? So you begin receiving data from the client once you've accepted them, and you begin looking for more connections. And it says, okay, I'm going to store any data I get in buffer. I'm going to start storing it at the beginning, and I'm going to try to read the full length of the buffer. There's no socket flags. Once we receive data, we're going to call this method, and we're also going to pass this variable or this value into the result. So once we receive data, what we want to do is get that connection right off the bat. So, here's our connection between you and the client, and this is where the object state is located. Now, as you see, there's an error. It says, wait a minute. Client socket is equal to result dot async state. Well, yeah, that should be right if async state is a socket. But the thing is async state is an object. You can put any object you want into the state. So you need to say, hey, this is a socket, and then it's all good. Once you have that, you can now end receive. And give it the result. And boom. You've now received all the data. But what end receive does is it actually gives you the amount of how much data it's received. So, just you can say, okay, the buffer size is equal to however much data the client, or we're receiving from the client. And once you have this information, you can, what you want to do is you want to create a shadow clone of the buffer before anybody else uses it. So what you want to do is you want to make a new byte array, and I call this packet because that's what it is. It's a packet that you've just been sent. And you want to make it the size of however much data you've received, because there's no point to make it bigger than that, and you definitely don't want it smaller than that, or else you can't receive all the data. So once you've made a new packet and it's the size of how much data you've you're going to receive, you copy what's in buffer to packet. And that's because all the data is in buffer right now. I would actually put that afterwards. But yeah. So now we can use array.copy. And buffer is the array that contains the data. We are copying to packet for however long packet is. Because buffer is probably going to be larger than packet is. But we only need to copy however much packet can hold. So that's what's up with that. So now all the data we've received is in packet. We then handle the packet and begin receiving again. There's one thing I forgot to mention is you need to make buffer become a new byte array every time. What this basically does is it just wipes any data that's inside of buffer, and that's a pretty big must every time before you receive, or else you might end up with previous old data inside, and that's pretty bad. So yeah, make sure you do this every single time. And that's basically how it's all set up. The way you use it is you create a server socket variable. And you bind it, which is the first step. You begin listening, which is the second step. And you begin accepting, which is the third step. And the reason there's a forever loop in here is because, like I said, an asynchronous socket is non-blocking. So if you run these three methods, even though it's supposed to be waiting and listening for connections, your program's just going to end because it lets the rest of the program execute while it's doing its thing. So that's why you need one of these in here. So yeah, I mean, if you run it, it'll work. You're not receiving any data right now, but you know, that's for another tutorial. You can receive data. There's no functionality for sending at the moment. But yeah, this is basically what's going on. In the next tutorial, I will show you how to handle a packet and build a custom packet structure. And we might be able to get to client stuff, maybe not, but we will find out once we get there. So yeah, that's about it for now. And yeah, this tutorial was basically covering how to set up a socket system. Next tutorial will set up or show how to handle any data you receive and do stuff with it. So yeah, I guess have a good one.